this class tomorrow. Okay, but on Thursday you will have a review of the 3 sections that we have gone over, and then on Friday you'll take a short quiz. So again, it's just the 3 sections. It's ratios and proportions, and then what we did yesterday was setting up proportions of similar polygons. Today we're going to go over similar triangles. So it's very similar to what we did yesterday.
Very similar.
Yep, with similar triangles. This was very funny. All right, so we are going over similar triangles today. I'm going to get out these highlighters here. All right, so in order to prove you have similar triangles, you have 3 different theorems or postulates to do so. So the first one is angle-angle similarity. Okay, so angle-angle similarity, we write as AA with the similarity symbol. Okay, so in order to prove that your 2 triangles are similar, you need to have 2 pairs of corresponding angles congruent. So angle A and angle X are congruent in this first one, and angle C and angle Z are congruent. Okay, so you need 2 pairs of corresponding angles that are congruent to each other. If you have that, then you can say the 2 triangles are similar by angle-angle similarity. Okay, the next one is side-side-side similarity. Okay, we just write side-side-side and then similarity afterwards. Okay, so with this one, you need to make sure that your corresponding sides all have the same ratio. So it's kind of like what we were doing yesterday. So if I have side AB and its corresponding side XY, and I write out that ratio, okay, it has to equal side BC to its corresponding side ZY. Okay, so those 2 ratios have to be the same, and side AC to XZ have to be the same. Okay, so all 3 of your corresponding sides ratios have to be the same. If they are, then you can say those triangles are similar by side-side-side similarity. Okay, the last one we have is side-angle-side similarity. Okay, so side-angle-side similarity. So this one you need an included angle, just like we did when we used side-angle-side in congruent triangles. That angle has to be included between your 2 similar sides. So here I have angle A congruent to angle X. Okay, that means my ratio of sides that I need to be similar would have to be AB and its corresponding side XY, so I could make a ratio of those sides. And then I would need AC and XZ. Okay, so that angle is between those sides that you would make those equal ratios for. Okay, so again, side angle side, you need 1 angle congruent, and then your ratio between your sides here have to be the same as well. Okay, so we are going to use these to state if our triangles below there are similar. So in problems 1 through 4, we're going to determine whether the triangles are similar. If so, we'll write the similarity statement. Again, that's this triangle similar to that triangle. And then we're going to just kind of explain our reasoning as we go here. So this first one, whenever you see these arrows, again, those mean those are parallel lines, right? when you have parallel lines, you want to look for congruent angles within your picture. Okay, so if these two lines are parallel, and this line right here is a transversal, okay, I know these two angles have to be congruent because they're alternate interior angles. You could do the same thing with angle X and angle W, okay? But I'm going to pick an easier angle as well. What other two angles could you say are congruent? Yes. Okay, so I can say those middle angles there are congruent to each other. So angle XZY and angle VZW, because they're vertical angles. Okay, so I have right now angle XZY is congruent to angle VZW. Okay, so I have one angle, and then I also had these two angles. So I have angle XYZ is congruent to angle ZVW. Okay, so I have two pairs of congruent angles within these triangles. So yes, these would be similar. Okay, why are they similar? Which reason from above here? Yes, by angle-angle similarity. And then lastly, what I want to do is write out that similarity statement. Okay, so my similarity statement here would be triangle. I'll start with X, go to Z, and then Y is similar to triangle. Since I started with X in this triangle here, I need to start with W in this triangle here. Then I went to Z, so again I'll go to Z, and then finish with V. Okay, so that has to go in that specific order. Okay, so that was our first example. So these are similar by angle-angle similarity. And I wrote out those congruent angles for you there. Questions on the first one? All right, then for number 2, I already see I have one pair of congruent angles. Okay, so angle A and angle F are both 90 degrees, so they are congruent to each other, right?
Yep.
That means I need my sides surrounding that angle to be proportional. So I'm going to use side AB right here and side DF. And I also need to use side AC and FE. However, I don't have FE. Okay, so you have to make sure you're looking specifically at that. But this is a right triangle. Can I find that last side? Yes. Okay, since this is a right triangle, okay, I can solve for this side by using the Pythagorean theorem. Okay, so all I have to do is take 6 squared plus x squared is equal to 10 squared. So I have 36 plus x squared is equal to 100. Subtract 36 from both sides. X squared is equal to 64. Take the square root. Again, when you take the square root of both sides, you do get plus and minus. However, we're using the Pythagorean theorem, finding a side length. So we only need the positive value of that, which is 8. Okay, so FE would have to be 8. Now, I do want you to notice how I highlighted this because I knew that side was going to be 8. So in this triangle, AB is 3, right? That's your shortest side of that triangle, correct? in this triangle, I highlighted DF to be its similar side because 6 is its shortest side. So you always want to match up the smallest with the smallest in the other triangle. Okay, you don't want to switch around. So sometimes it's hard to tell when your triangle turns like this. Okay, so your smallest one matches to your other smallest one. And then 4 would be my next one, and 8 for that one. Okay, does that kind of make sense? Yeah? All right, so from here, since I have one pair of congruent angles and now I have the sides surrounding that, because I'm trying to see if this could be a side angle side similarity, I want to write out the ratio of these sides and then compare them. So from triangle ABC to DFE, using 3 and 6, so I have my ratio of corresponding sides there. Reduce that ratio to 1/2. I want to do the same thing to my other corresponding sides. So AC is 4 over FE is 8. Okay, so there's another ratio of sides. And again, that's 1/2. So you want to make sure that those ratio of corresponding sides are the same. They're both 1/2. So yes, these two triangles would be similar. Okay. Okay, by which one of our theorems above? By side angle side. Okay, then I just have to write out my similarity statement. So I have triangle ABC is similar to triangle FDE. Okay, how are we doing so far? All right. All right, then looking at number 3, for this one, it looks like we're more leaning towards a side-side-side type similarity. So with that, I want to find the ratio between corresponding sides for each and see if they're all the same. So again, I'm going to use my highlighters here. My smallest side in my triangle to the left here is 6, right? Okay, so that one will correspond to the smallest side in my other triangle, which is 4. Okay, my next smallest side is 8, so that middle side, that corresponds to my next smallest side in my other triangle, which is FG, or 5. And then my last sides here, my largest side on the triangle, or in the triangle on the left, is VU. My largest side in this triangle here is FH. Okay, so I like to highlight them just so it's a little bit easier to set up those ratios. Okay, so now I'm going to check each of the ratios. So I'll just start with my pink ones that I have right here. So going from this triangle to that one, I'd have a ratio of 6 to 4. And again, you want to reduce that ratio to 3/2. Okay, just moving around my triangle here, I have my side of 12 to my side of 8. Okay, again, reduce that ratio. Both of those values divide by 4. So 12 divided by 4 is 3. 8 divided by 4 is 2. So far, so good. My last set of sides, right here, I have a side of 8 to a side of 5. That one doesn't reduce. Do all of these match? No. So since they don't match, we would say these are not similar triangles. Okay, so they're not similar since your sides are not proportional. Okay, because your sides all need to be proportional for those to be similar triangles. Okay, questions on number 3. Okay, I want you guys to do number 4. So find the ratios of your corresponding sides, see if those are similar. All right, so I did highlight which sides are corresponding in number 4 here. So I'm going to start writing out the ratios between those corresponding sides. So I have 20 to 8. Okay, that reduces to 5 to 2. My next one here, I have 10 to 4. Again, reduced ratios 5 to 2. And then last one, I have 15 to 6. Again, 5 to 2. Okay, so all 3 of these have the same reduced ratio. So yes, they would be similar. By side, 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 similarity. And then I can say triangle JKL is similar to triangle SQR. Now you may have switched your letters around, but you do want J to be with S, K to be with Q, and L to be with R. Okay, any questions on proving why these triangles are similar? Or why they would be similar? All right, then at the bottom we do have some problems where you're just finding the value of x. So first what you want to do is make sure these triangles would be similar, and then you want to set up a proportion to find that missing side. So in this one we're trying to find KL, which is the side right here where that x is. Okay, now these two triangles would be similar by angle-angle similarity because they have two pairs of congruent angles. Now that helps you so you know which side compares to the other side. So I know XY and JK are my corresponding sides because they're between my two congruent angles. Okay, so I can set up a ratio of those corresponding sides there. So 5 to 4. Okay, so those are my corresponding sides. I'm trying to solve for x here. X's corresponding side is 15. Now in my first ratio, since I started with this triangle, I again want to start with this triangle. So I have 15 over its corresponding side of x. Okay, then I just have to cross multiply. So I have 5x is equal to 60. Divide by 5. I get x is equal to 12, meaning KL equals 12. Okay, so it's very similar to what you guys did yesterday. You're setting up that proportion of corresponding sides. Okay, so I was solving for KL. Wrong KL. Okay, questions on this first problem here? All right, then 7 is a little bit different. You have one triangle within another triangle. So your smaller triangle is triangle RTS, and your larger is QVS. Now, if you don't like how you have two triangles within one, what you can do is take out the smaller one and redraw it. So if I want to redraw triangle RTS off to the side here, okay, I'm just going to relabel it with its side lengths. So I know RT is 3. Angle T is a right angle. And TS is 12. Okay, so now I have my two separate triangles, and I don't have to worry about this piece or this piece in my larger triangle. So now it's a little bit easier to look at from one triangle to the next. So if you do have to redraw that smaller triangle on the outside, do that. If you don't feel you need to and you understand what's going on, then don't worry about that. So I'm trying to find VS, which is X right here, my larger triangle. So again, we're just going to set up a proportion between corresponding sides. So I have corresponding sides here, QV and RT. So I can set up a ratio of those two sides. So we have 5 to 3. Okay, then my other corresponding sides, including X here, would be VS to TS. Okay, so I'd have X to 12. And those two ratios have to be equal to each other to set up that proportion. Okay, so from here again, all you have to do is cross multiply. To get 3x is equal to 60. Divide by 3. Get x is equal to 20, meaning VS is equal to 20. Okay, so again, if it helps, draw that triangle, that smaller one, on the outside so you can go from one to the next as you do that. Okay, so again, you're just setting up those equal ratios in that proportion to solve. Questions on those two? All right, then I'm going to pick a couple problems on the back here. So we're going to skip the first one because I think you guys can do that one just fine. I'm going to do number 2 on the back. So I'm just going to find the measure of x. So this one is really similar to the one we just did on the front, where you have a smaller triangle within a larger triangle. So again, if you want to draw that smaller triangle on the outside, you can do that. So here, okay, I would have triangle GHW. Okay, side GW is 26, and side HW is 20. Okay, now I'm going to look back at my larger triangle, because in order for this side of GW, I need to have, to set up that ratio, I need to have this entire length from G to U. Okay, so that means I have to add those two lengths together. So that entire length is 26 plus 13. So it is 39. Okay, so your ratio, this is why I want you to kind of write that triangle off to the side. Your ratio for those two corresponding sides is not 26 to 13. Okay, 13 is not part of a triangle. So 13 would be part of this trapezoid here. Okay? So that's not part of a triangle. You need the entire side of 39 compared to the smaller triangle side of 26. Okay, so I can set up this ratio of 39 to 26 equal to, since I started with my larger triangle, again, start with your larger triangle side here, which is x, to its corresponding side in the smaller triangle that I drew out to the side here of 20. Okay, now again, all you have to do is cross multiply. So I have 26 times x is equal to 39 times 20. Divide both sides by 26. And yes, x is equal to 30. Okay, so you do have to be careful while you're setting up these proportions. Okay, next one I want to do is this one. Okay, again, this one's a little bit different. So, again, you have a smaller triangle within your larger triangle. So again, I'm just going to draw it off to the side real quick here. Okay, so I have triangle LPM. Side LP is 7.2. Side LM is X, and PM is 16. Okay, now this is my smaller triangle. Now again, for my larger triangle, I need my entire side length. Okay, just like we did before. So that means I need to add 8 and 16 together. Okay, so that entire side length of VM is 24 because that 24 corresponds to that 16. Now what about this side K to M? What would that one be? 9x. Not 9x. How did I get 24? You added them. So you need to add them together. So this will be 9 plus x as that entire side length. Okay? So you have to add those together to get your entire side length of that larger triangle. Okay, now I can set up my proportion of corresponding sides. Okay, since I'm solving for x, I have my larger side and then my smaller side are proportional. So I have 9 plus x to x. Okay, so my larger, smaller triangle. Since I started with my larger triangle, again, start with your larger triangle. So that would be 24 to its corresponding side in the smaller triangle is 16. Okay, next we just have to cross multiply, so I have 24x. When you do this one, make sure you distribute that 16 to both terms. So you have 16 times 9 is 144. And then 16 times x, so plus 16x. From here, I'm going to subtract 16x from both sides to get 8x is equal to 144. Divide by 8. And x is equal to 18. So LM equals 18. Okay, does that make sense? Finding that smaller triangle, take it out of the bigger picture so you can go from one side to its corresponding side. Make sure in your larger triangle you do find that entire length of the larger triangle. You're not using that small piece like in number 4, you're not using just 9. Okay? That side of 9 doesn't create a triangle here. Okay, it has to create that triangle. So you want that entire length, so you have to add it together. Okay, any questions? Okay, then I do want you to